Okay, let's dive right in. We pour so much time and energy into making sure our software is secure before we ship it. But what happens the second it goes live? Well, the world changes, new threats pop up, and all of a sudden, the game is completely different. Today, we're going to explore that really critical phase, security after deployment.
And this right here just nails the core problem. It's like software has two different lives. On one side, you've got the build phase. It's a fortress, right? We're super meticulous, scanning everything, checking every little component, locking it all down. But then it gets deployed. And it enters its second life, a dynamic, kind of chaotic world where what was totally safe yesterday is a huge vulnerability today. It's a fundamental disconnect.
So to really get a handle on this, we need to understand the way we've traditionally thought about security. And we can call that model the security snapshot.
Think about it like this. Every static analysis scan, every dependency check you run in your pipeline, it's like taking a photograph. It gives you a perfect, crystal clear picture of your security posture at that one single frozen moment in time.
But here's the kicker. Here's why that photograph just isn't enough. The source material is really clear on this. The vast majority of vulnerabilities are actually found and disclosed after the software is already out there running in production. So that single snapshot at build time, by definition, it's missing almost all the threats that are going to pop up later.
And this reliance on a single snapshot in time, well, it creates a massive and, frankly, a really dangerous blind spot in our defenses.
So what's actually happening inside that blind spot? Oh, a ton. New vulnerabilities, CVEs, they get published every single day. The dependencies of your dependencies can change without you even knowing. Your containers are constantly being rebuilt and redeployed, and server settings can just drift over time. It's a state of constant change that your initial security snapshot knows absolutely nothing about.
For years, our entire security process has been built around answering this one question. This was the gold standard. We built these complex pipelines, we bought expensive tools, all just to get a confident yes before we hit deploy.
But we need a huge shift in our thinking. The truly important question, the one that actually matters for protecting life systems and our users, is this one. It moves us from looking at a historical record to dealing with present reality. It's a difference between asking about the past and actually securing the now. Okay, so we've defined the problem. It's big, it's dynamic. So how on earth do you answer that question, is this safe right now? Well, the answer comes from a really elegant piece of technology called a digital twin. A digital twin, in this context, is pretty much exactly what it sounds like. It's a live, real-time replica of your production environment. Not some static diagram, but a living, breathing model that is continuously updated to reflect every single component, every container, and every package that is actually running at this very moment.
And you know what the best part is? It's how it's built. You don't have to install a bunch of new, heavy tools into your systems. Instead, it does something really smart. It federates, or, it brings together metadata that already exists. Your source code history from Git, your built artifacts, your deployment logs from Kubernetes. It just pieces together the full picture from all the clues you're already generating.
And this right here is the absolute game changer for operations and platform teams. Because it's built from existing metadata, it adds zero runtime instrumentation, no additional operational footprint. You get complete, real-time visibility without slowing down your production systems one bit. It's huge.
Now, this is where things get really powerful, because this digital twin tech lets us transform a key security tool, the Software Bill of Materials, or SBOM.
A standard SBOM is a great idea in theory, but it suffers from the exact same problem as our old security scans. It's a snapshot. It's like a paper receipt from the grocery store. It's a perfect list of the ingredients you bought on Monday, but by Friday it's already out of date and tells you nothing about what's actually in your fridge right now.
But when you power that SBOM with a digital twin, it stops being a static piece of paper and becomes a living asset. It updates itself in real time. So when a new critical vulnerability is announced, you don't have to scramble and start a fire drill. The living SBOM can instantly tell you, hey, that vulnerable thing, it's running right here.
And this just brilliantly shows you the practical outcome. You go from the chaos of before, getting some vague alert and having to manually figure out if you're even affected, to the calm, focused precision of after. The system tells you exactly which project exposed so you can take immediate targeted action. No more guesswork.
So let's zoom out for a second and just appreciate the bigger picture this creates. We're finally able to achieve real, meaningful security after the software has been released. This is especially powerful for, say, open source maintainers and small teams who are just constantly overwhelmed. It drastically reduces the noise from false alarms, it automates all that manual work of tracking down vulnerabilities, and by providing a clear, measurable security posture, it just builds so much more trust with users. This table, it just perfectly summarizes the entire paradigm shift. We are moving away from the old way on the left, periodic scans, document-driven, snapshot-based security, and we're moving to this new model on the right that is all about real-time visibility and continuous operational security.
Ultimately, this isn't just about some new tool. It's a whole new philosophy. As the source material puts it so well, security is no longer a single event or a static document. It becomes this living process that is continuous, that's built right into your operations, and that's shared across the entire community.
And that kind of leaves us with a final thought to chew on. This idea of replacing a static snapshot with a live, continuous feed is incredibly powerful. It solves a huge problem in software, but it makes you wonder, what other important snapshots in our work, or even in our lives, are dangerously out of date and really need to become live feeds?